Hey everyone, this is Professor Mankowski, and in this video we're going to take a look at some review aspects about the normal distribution, and then we're going to go into some brand new exercises. So we found out in the last video that if we're doing a question about the normal distribution, there's two things that we have to do. We have to go ahead and use our Z formula, and then we have to use our Z tables. So if it turns out that you answered a question and you didn't use the Z formula, you did not use the Z tables, what does it mean about your answer? Means it's definitely going to be wrong. So we have to remember that there's always going to be two parts to the questions in the normal distribution. Now let's take a look at some really important parts of the Z tables. Let's say that you went ahead, you had a normal distribution, you knew an average, you knew a standard deviation and an X value, and you ran your Z formula on that X value and it came out to be negative 5.75. And now you need to know how much area is less than 5.75 standard deviations below the mean. So we go ahead, we pull out our Z tables, and we go and we look to see find our area matching to negative 5.75. The only problem is we don't seem to get any close to that, anywhere close to that on the Z table. In fact, the most negative value we get is negative 3.49. So how do you figure it out? What's the answer? Like, is it something wrong in your calculations? And maybe you've checked your calculations over and you're still getting Z equals negative 5.75. So what's going on? Here's the answer. In our Z tables, we have a little footnote that helps us figure this out. At the very bottom, it gives us a note and it says for Z values less than 3.49, use 0.0001. And here's why they're telling us that. We know from the empirical rule that if we're 3 standard deviations below the mean, we're in a very rare position, and hardly any data is going to be less than that number of standard deviations below the average. And we don't want to say the area is 0 because we want to be a little more careful. So what we do is we say the probability is 0.0001. So anytime we have a Z value less than negative 3.49, we're going to use 0.0001 as our area. Now, what if we had this value, Z equals 5.75? So this time we go into our Z table and we can't find 5.75. The closest we find, in fact, the highest we get is 3.49. So what do we do? And the answer is there's going to be something very similar that happens. There's a little footnote that's going to tell us if we have a Z value greater than 3.49, we're going to use 0.9999. And it makes sense because the empirical rule says if you're more than 3 standard deviations above the mean, very few members of the population are going to be higher than you. Almost the whole population will be less than you. So we don't want to say 100% is going to be less than you. Instead, we're going to use the value 0.9999 because 99.99% of the population should be less than 3.49 standard deviations above the mean. Okay. Now let's talk about in the normal distribution why they're calling it the standard normal distribution on our Z tables. Like, did that mean something special? And the answer is yes, it does mean something really special, and we're going to end up using that for almost the rest of the whole semester. Let's take a look. Anytime we refer to the standard normal distribution, we're talking specifically about a normal distribution that has an average equal to 0 and a standard deviation equal to 1. Now, let's do a curve sketch and see a little bit more deep what's going on in there. If we go ahead and we mark the average by writing U is equal to 0, so that's just going to be our placeholder for the average. And we're going to go 1, 2, and 3. Those are going to be our 3 digits on the high side. And we're going to have on the low side -1, -2, and -3. And these numbers are standing for different positions or different distances of standard deviations we are from the average. So if we are at the 1, for example, that means we're 1 standard deviation above the mean. If we're at the 2, we're 2 standard deviations above the mean. If we are -2, that means we're 2 standard deviations below the mean. And the implication is that anytime we run our Z-score, as soon as we take an X value and convert it to a Z-score, we've positioned ourselves on the standard normal distribution. And that's why they call the Z table the standard normal distribution. Okay, so what we're going to learn how to do is read the normal distribution curve backwards. So far, we've been reading it forwards, meaning somebody gives us a population that's normally distributed, we get an average and a standard deviation, and an X value, and we find the probability associated with that X value. But a new thing that we can do is if somebody gives us the probability first, we can find the X value that corresponds to that probability. And you might be thinking, why in the world would I need to do that? Why would I need to read the Z table backwards? And the answer is because there's lots of questions we can answer by doing it. Let's say that you want to become a firefighter. You have to go to a firefighter academy, and they won't take just anybody in the fire academy. You have to go and you have to take a basic skills test. And if you score high enough on the basic skills test, then you can get an interview with a fire department. So if they were to tell us, maybe for a particular fire department, that on that exam, the scores happen to be normally distributed, the average is 100, the standard deviation is 10, but they're only going to take the top 10% of the people that place on that test, we might want to know what score do we need to cut off for an interview, because that could help us prepare for the test. So that's the kind of questions we'll be able to answer by learning to read a normal distribution curve in reverse. So let's get really well practiced at how to do this. First thing that we're going to do, and I have to move a dashboard function out of the way here. First thing that we're going to do is we get an area. It's 0.0516. We need to find out what's the Z value that matches that area. So something that's going to help me figure out what Z table to look at, like should I look at the positive Z table or the negative Z table? My first clue is going to be that the area 5.16% is less than 50%. So that must mean it came from a X value that was less than the mean. So I'm going to go ahead, I'm going to bring up my Z table here, the negative table, and I need to find in the center of the table, in the midst of the areas, which one matches 0.0516. And here it is on our chart. That's going to match up with the Z score of negative 1.63. So I'm going to go ahead and write that in. That means that about 5.16% of my area is going to be less than 1.63 standard deviations below the mean. Let's do another. This time we want to find the Z value that matches the area of 0.8888. And this means we're going to switch to the high side because we're greater than 50%. And I'm going to go inside my Z table. I'm going to look for the closest area that matches 0.8888. And here it is right away. So it's going to turn out to be that my Z score will be 1.22 that matches. Let's do a few more. This time I'm going to look for the Z value matching area of 10%. And notice that this time the probability is with a percentage. And that's to help us getting practiced at converting back and forth, because we're going to have to do a lot of that. The area percent as a decimal would be 0.1000. Now, as we look that up, pause the video if you need to for a minute to search it out. Okay, this one's a little bit different. It's a lot more difficult because we don't find 0.1000 on the chart, do we? What we're going to do instead is we're going to get the closest area to that, and that's going to come in at 0.1003. So this means our Z value is going to be negative 1.28, which is exactly the one that we're going to take. Let's do one more. This time we're going to go for the Z value matching the area of 5%. So pause the video if you like for a couple minutes to see if you can identify which one comes the closest. Okay, so it's going to turn out to be that this one's a lot more challenging because we don't have one value that comes the closest. We actually have two. We're right smack in between 0.0505 and 0.0495. So how do you figure out what to do? The answer is we're going to take the Z score that's furthest from 0. That's going to be negative 1.65. There is a science of why we're taking the one that's furthest from 0, and we're going to find that out in chapter 7. Okay, so now that we've gotten a really good idea how to read the Z table backwards, we're going to start to get into some probability questions. And our first one has to do with warranties. So if you've ever had an issue with your car and you had to bring it into your merchant, and your car dealer, and they're going to try to take a look at it for you, you're hoping that it's under warranty. And we start to wonder, does the warranty, is it still in effect? Has it lasted long enough? And there's actually a science to how a manufacturer will figure out a warranty length, that is an expiration amount and expiration amount of time. And this next question is exactly about that. So pause the video for a minute or two, read through the question. Okay, so inside of here, we have a manufacturer and they're making wristwatches, and they're telling us They happen to know the average wristwatch goes for 25 months. The standard deviation is 5 months. And they want to figure out exactly how long to make the warranty for. So after the first 10% of the watches are exchanged, the warranty is, as if by magic, it's going to be timed so it expires exactly then. So how do you figure this out? Like, how many months should the warranty be for? So exactly 10% of the watches are going to die by the time the warranty expires. Now, our first clue in here is that they told us the distribution is normal. So we're going to go ahead, we're going to start to sketch a normal distribution. And what I'm going to do is I'm going to go and I'm going to shade the lowest 10% of the area in my curve. And I'm going to mark that as that's my lowest 10% of the area. Next, what we're going to do is we're going to go into the Z table and we're going to find the Z value that comes closest to the lowest 10%. That's going to be negative 1.28. So I'm going to go ahead and mark that down. Now, what do I do with all this information that I've gotten so far? I need to bring this back to my Z value, my Z formula. And I'm going to take a really good look at my Z formula and see what kind of work I can do on it. I know a Z value already. I know a mu and I know a sigma. So technically there should be enough information to rearrange this whole equation and solve for X. Here's exactly how we're going to do it. I'm going to put my same formula back up on the screen here, and I'm going to divide my Z value by a 1. So now what I can think of is, how do I dismantle the fractions on both sides? And my answer is I can use cross multiplication. So if I cross multiply both sides out, I'm going to find out that Z times sigma is equal to X minus mu. So if I isolate X, what I'm going to find out is my X is going to be equal to Z times sigma plus mu. And this is a shortcut formula that we can use anytime we have a question where we get the area first, and we need to find the X value that matches that area. This will be our new shortcut formula. So now we're going to bring this back to the question, and all we have to do is plug in our values for Z, sigma, and mu. And we're going to do a 5 for sigma, a 25 for mu, and it lets us know the computation comes out to be 18.6. So for the manufacturer, if they don't want to exchange any more than 10% of the watches, the warranty should be set for no more than 18.6 months. Let's take a look at another practice exercise. Pause the video for a couple minutes and read through the question if you need to. Okay, so it looks like we have a contractor that's going to build homes. The average house in their market that they want to do is 1810 square feet, or 1,810. And the standard deviation is 92 square feet. And they need to figure out between what two square footages should they build so they capture precisely 80% of the market. Now, they've told us that we're normally distributed, so we're going to start by sketching a curve here. In the middle this time, we're going to go ahead, we're going to shade the 80% of our curve. And on the low side and the high side of this red zone here, we're going to find the minimum and the maximum. So what this means is we have to go and figure out what X value matches the minimum and what X value matches the maximum. So the contractor knows exactly what size homes to build. So now how do you do that? Because we don't have any kind of a Z table that works with in between probabilities, in between areas. So how do we manage this? And the answer is we have something special called alpha. And alpha is going to help us figure all this out. So alpha is our new symbol. And alpha is the area left in the tails. So how do we calculate alpha? We're going to do 1 minus the area in the center, because if we have 80% of the area in the center, 1 minus that would tell us we have 20% of our area left to go for the tails. Now, how much area is left in each tail? If we take alpha, divide it by 2, that's going to let us know we have 10% in each tail. So I'm going to go ahead, I'm going to mark, I've got 10% on my left side, 10% in the tail on the left, and 10% in the tail on the right. So now all I have to do is I have to use my Z table to figure out what's the Z score that's going to match the lowest 10% and the upper 10%. And we're going to use a really special trick to make this easier. For the left side, we're going to have our Z value is negative 1.28. And here's the trick. If it turns out that 10% of your area in the curve is less than 1.28 standard deviations below the mean, Because the curve is symmetrical, it has to be the case that 10% of your area is also more than 1.28 standard deviations above the mean. So we can get the high side without even looking at the z-table. So now that we know our z-scores, now we can start to fill into our formula. So the minimum and the maximum are going to be using the same formula. The only difference in the formula is going to be the sign on our z-value. So if we fill in our formula for the left and fill in for the formula on the right, the only difference is going to be our z sign. Negative 1.28 on the left, positive 1.28 on the right. If we fill out our formula, we're finding out that if that contractor wants to build houses that'll include the middle 80% of the market, they don't want to go any lower in square footage than 1,692, and they should exceed no more than 1,927 square feet.